Hello everyone and welcome back to Bard of Science. Today in this video, let's talk about the Mars Orbiter mission, aka Mangalyaan. You might be thinking, what's the point in making the video after so long? But let me remind you, on this very same day of 24th September 2014, Mangalyaan mission had become successful, which had made India the fourth nation to reach the Martian orbit. So I thought, why not make a video in the remembrance of this mission, and also let's talk about some technical aspects of the mission. So without wasting any further time, let's get started. Although the Mars Orbiter satellite was launched on 5th November 2013, the story began back in the year 2008 with the announcement of the mission by ISRO's then chairman G. Madhavan Nair. The MOM mission started with the feasibility study by the Indian Institute of Space Science and Technology. After the launch of the lunar satellite Chandrayaan-1, the Mars Orbiter satellite was completely designed and developed at ISRO Satellite Center in Bengaluru, and the 5 essential scientific instruments were also mounted on the satellite, and the satellite was shipped to Sriharikota for its integration with the PSLV launch vehicle. After the integration of the satellite with the launch vehicle, it was finally time to launch. The Mars Orbiter was launched on the PSLV C-25, the XL version of the launch vehicle, which has 6 extra strap-on solid rocket motors to provide extra thrust. The PSLV launch vehicle has a maximum thrust of 4,800 kilonewtons with an extra thrust of about 719 kilonewtons from its strap-on boosters. The PSLV launch vehicle injected the Mars Orbiter satellite into a very highly elliptical Earth parking orbit with a perigee of 264 kilometers and an apogee of 23,550 kilometers. The perigee is the smallest distance between the orbiter and the surface of the Earth, and the apogee is the largest distance between the surface of the Earth and the orbiter in its orbit. The orbit of the satellite had an inclination of about 19.2 degrees with the equatorial plane of the Earth. Now, after putting the satellite in its designated orbit, it had to escape the sphere of influence of the Earth. So, a series of orbit-raising maneuvers were performed to raise the height of the satellite, and by keeping the same perigee but increasing the apogee. Whenever the satellite approaches the perigee, the speed of the satellite is the highest, and at the same time the onboard thrusters of the satellites are fired so that an increase in the speed is achieved and the satellite could be pushed into a higher elliptical orbit, keeping the same perigee but increasing the apogee. So after 6 orbit-raising maneuvers, the orbiter was in an elliptical orbit having a perigee of 264 kilometers and an apogee of about 1,92,874 kilometers. In this orbit, the speed of the orbiter at the perigee was about 11 kilometers per second. It is very close to the escape velocity of the Earth, which is about 11.2 kilometers per second. So, a final push was required for the satellite to escape the sphere of influence of the Earth. So, on 30th November 2013, the onboard thrusters of the satellite were fired near the perigee to impart a delta V of about 200 meters per second, making the total speed of the satellite about 11.2 kilometers per second, which is the escape velocity of the Earth. And for the first time in the history, India had crossed the Van Allen belt. Van Allen belt is the sphere around the Earth which is comprised of very highly charged particles arising from the solar wind. This is the last point until which the magnetic field of the Earth has an influence. This phase of the mission was called as the transmass injection. The transmass injection was a very difficult phase to carry out. it required an extreme precision of about 99.9%. Yes, you heard that right. Here the 99.9% performance refers to the thrust produced by the onboard thrusters of the satellite. A slight over or underperformance by the onboard thrusters meant the failure of the mission at the point. More than 50% of the Mars mission have failed at this point itself. Now, to give you a slight insight of how difficult this phase is, let me give you an example. Think that you are standing somewhere in India. Let's take Mumbai for example, and think that you had to shoot a golf ball straight into a hole located in Los Angeles. You might be thinking, what's the big deal? The twist is that the hole was moving. So extremely high precision operation was required to carry out this phase. Otherwise, the mission would have failed at this point itself. After the satellite had escaped the sphere of influence of the Earth, it was set on a cruise path to the Mars. The cruise path was calculated based on the human transfer orbit between Earth and Mars, which allowed for the minimum energy requirement, resulting in a very light satellite and the minimum fuel requirement. Earth and Mars align properly for the human transfer every 26 months. The satellite traveled a distance of 780 million kilometers in the human transfer orbit around the Sun to reach the Mars, which took around 10 months for the satellite. This was the most difficult phase of the mission to be carried out because if the satellite approached the Mars and could not be captured into the Martian orbit, it meant that the mission had failed and there was nothing that could be done to correct this. When the satellite was very close to the Mars, it was moving very fast relative to the Mars, and if it encountered the Mars with this velocity, it would definitely miss the insertion into the Martian orbit. So the speed of the satellite had to be reduced. So to do this, the satellite is reoriented so that the thrust vectors are pointing in the right direction, and then the onboard thrusters of the satellite are fired in the reverse direction to achieve a velocity reduction at a rate of 1094 meters per second, and this burn lasted for about 24 minutes. During this phase, the communication between the satellite and the ground station on the Earth gets blocked by the Mars itself, and this phase was also called as the eclipse phase. So, all the necessary operations and the decisions had to be taken autonomously by the onboard computers of the satellite. After the successful Mars orbit insertion on 24th September 2014, history was created. India had become the fourth nation in the world to reach the Martian orbit. Now let's talk about some interesting facts about this mission. It was the first Mars mission in the world to succeed at its first attempt. It is the most economical interplanetary mission, costing only 74 million US dollars, which is very less compared to an average budget of the Hollywood movie. It was the project which got realized in the shortest time of 18 months from the phase of conceptualization to the launch. The satellite, programmed with full-scale onboard autonomy, capable of self-diagnosing and self-repair. This was a very important feature of the satellite. The signal from the satellite to the Earth or from the Earth to the satellite took almost 20 minutes to travel, and it would be very late before responding if anything went wrong. So, the satellite was programmed in such a way that it could self-diagnose the problems associated with it and apply a fix to the problem. And it was the youngest team at ISRO that worked on this mission. I hope you liked this video. Don't forget to like, share and subscribe. Thanks for watching and I'll see you in the next one.